All right, and for our safety indicator stickers, you can see we have on top of our upper accumulator lid, we have our accumulator always energized sticker next to our accumulator indicator light and a danger high voltage sticker. You can also see that there's one along all sides of the enclosure as well. And then moving over to the lower part of the accumulator, which houses our battery segments, you can see the danger high voltage sticker, the accumulator always energized sticker, and another danger high voltage sticker. Here's a look at the GLV tractive system spacing on our self-designed circuit boards. Starting with the electric discharge PCB, you can see that the shortest gap between tractive system and GLV is about 12.83 millimeters. I can prove that here. This board is conformal coated in the car. Unfortunately, I don't have a UV light, so that will have to be shown at Tech in Michigan, unfortunately. And here's a look at our high voltage PCB. So this houses our airs. Fusing, you can see that we have a tractive system GLV isolation barrier. You can see that the smallest point here is 8 millimeters. This board is also conformal coated, which will have to be proven at Michigan. Here's an example of that, about 8 millimeters. And going down to this side of the board, the shortest gap between tractive system plus and minus is across this isolated regulator, which is about 7.5 millimeters. This will also be under conformal coating as well. Okay, so here's a video inside the management side of our accumulator. So right here on the right, you can see our low voltage accumulator management system board. This board handles everything low voltage related to sending our cell voltage and temperature data to our CAN bus and monitoring those as well from our boards through ISOSPI. You can see that cable there. And then over here you can see our high voltage board. So this houses our airs right here. It houses our IMD, and then you can also see that there's a 3D printed piece sitting below the board, and this is so we can more efficiently route our bus bars and other things in our accumulator. So right here you can see our current sensor, for instance, and then over here are TSMP resistors. And here's another look around there as well. You can see that we have our tractive system fuse right here. It's 150 amps. Additionally, you can see the positive locking in our accumulator. You can see that at the fuse, at both ends of the fuse. You can see it at both the inverter positive and minus terminals, and there as well. Additionally, you can see that we do have some solder here. This is not conducting any current. This is our battery plus reference that we use. It's soldered like this so we can have shorter wire that doesn't need to be fused. Yeah, so here's another look at our accumulator. So basically, the way that we set up our maintenance plug configuration is to where it can be plugged in backwards. And additionally, you can get a look at our maintenance plugs here. You can see that there's no electrically conductive material exposed other than the contacts of the maintenance plugs themselves. Additionally, I'm going to quickly install everything here just so you can see that this can be done. Here's a video of the lower half of our accumulator. So you can see that the insulating walls here are made of aluminum and we have Kapton tape along them. Additionally, there's also a fire retardant Formex underneath this heat shrink here, and this is wrapped on every segment of the accumulator so we can have that barrier between each segment per the rules. Additionally, you can see in that gap where there won't be a Formex barrier, we have Formex over the aluminum here, which is held in place with Kapton tape. Additionally, you can see that the corners of our accumulator that have been welded have also been RTV'd to ensure that our accumulator housing is waterproof as well. Alright, here's another look before we install the Formex on the segments. So this is after we Kapton tape around all of our copper bus bars for the segment. So this is before we install the Formex. You can see there's a little bit on the side here, but that's not important at the moment. So you can see we have our thermistor sense lines coming up. So they run from the cells that they're measuring. They run up, and then there's a gap between the boards and the top cell. So you can see that that wire runs from here up to there, and this is how we're able to monitor our cell temperatures. So you can see that we have 5 thermistors here, 4 thermistors here, and you can see that they run in lines up like this. Another look at our accumulator segment here. So you can see that this is after we have installed Formex on the segment. So you can see here that this covers the entirety of the segment along all sides, including the bottom as well, and it's held in place with Kapton tape. So this is our fire retardant barrier between each segment. So there's 2 layers of this going in between each segment of the accumulator. Alright, so here's the accumulator after all 5 of our segments have been installed. So you can see that we have our ISO-SPI connector, which is how we communicate our cell voltages and temperatures to our accumulator management system. So right now you can see our thermistor leads sticking out. So after this we install our maintenance plug housing here. So you can see that this puts all of our maintenance plugs into place, and this is so we can't plug in the accumulator backwards. You can see that we have our one segment facing the opposite direction, so it'll go over like this, and then we will connect all the maintenance plugs. We'll look at our accumulator charging cart. Right now you can see that our accumulator is charging, and our voltage indicator light is presently on. I'll verify the functionality here by briefly turning off the charging cart. You can see that the light turns off, and I will re-energize the charging cart to begin charging again. And you can see that that light turns back on. Good. Okay. Here's a look at our charging cart setup. So we use the TV amp seal connectors. So you can see that we have our interlock there, which carries the current for our shutdown loop. Likewise, our accumulator. Likewise on the accumulator. We don't have any wires that are carrying high voltage current that aren't orange. You can see here, this is our charging lead here for the car. Additionally, down here you can see our measuring point using both red shrouded banana plugs.